Whoa, you caught me at a really bad time right now. Molecular compounds, naming those things, it's easy. Well, it's tricky for... Yeah, I can help you. Just 1 second. Molecular compounds are known as covalent compounds as well. They are nonmetals. Okay, so it's a combination of two or more nonmetals. For the purposes of this video, we're going to keep it simple and just do a combination of two different nonmetals. And so what you first need to know is that these are not filled with ions. Those are for ionic compounds. So they don't have charge. They're sharing electrons, and they're just happy in their own little way. These naming rules consist of using what are called prefixes. And these prefixes can be downloaded, looked at. I have some here for you. And they will tell the reader exactly how many atoms of that nonmetal there are in the compound. So let's go from the formula to the name. And here's a couple of examples. CO and CO2. Now the first two steps are really easy. Write down the names of both the first and second nonmetal. But of course the second nonmetal should have an IDE ending. We need to now affix prefixes, or how about fix prefixes to the fixing fix face, to each of these names to tell the reader exactly how many of those atoms there are. Now there is a special rule. Here is a disclaimer. If there's only one atom for the first nonmetal, you don't need to put a prefix. Now prefix means before, so we would put it here. So I'm going to leave those blank. So the first, for both of these, there's only one carbon, therefore we just name it carbon. Now oxygen, however, oxygen in this one, there's one oxygen, so we need to put down the prefix, and prefix means before, right here, mono. Now in this one it's monoxide, right? I didn't do very good room there, but it's okay, you get the point. And for this one, for this next one, we have two oxygens, so we would fix the prefix di, which means two, before the oxygen. How do you like that? So in this case, we have carbon monoxide, which literally means carbon, and one oxygen. One carbon and one oxygen. Read it again. Look at this next one. Carbon dioxide. One carbon, two oxygens. One carbon, two oxygens. That's all it is. Boom, magic. We have another example here. So step one, name the first nonmetal, which is nitrogen. Now in this case, we can see that it has two nitrogens. So if you want to right now, put the prefix on before you even write it. The prefix for two is di, so it would be dinitrogen. Dinitrogen. And what about this next one? We have three fluorines. Now, of course, you change the ending to IDE, so it would be fluoride. Trifluorine. Trifluoride, I should have said. So trifluoride. There we go, and that's the name. So dinitrogen trifluoride. It's that simple. A word of caution, my friends. Sometimes you will look at molecular compounds like this. NO2, or how about SO4? Now in this case, if you're doing this really quickly, this would be nitrogen dioxide, and this one would be sulfur tetraoxide. But sometimes people will get mistaken because they know how to do polyatomic ions, and they'll say that this one is nitrite. And they'll say this one is sulfate. Really quickly. That's wrong. Okay? This is super wrong. Wrong. These are molecular compounds. These are polyatomic ions. If you don't know what a polyatomic ion is, go check out the other tutorial. But if you saw that there was a charge on this one, then they would be sulfate and nitrate. But these are molecular compounds. Just erase them. I shouldn't have done that with my hands. Name to formula. Now this one is super easy. But I have to give you caution. Sometimes students will blend the rules for ionic and molecular compounds, and you can't do it. You got to keep it straight. When you're looking at a name like this, dicarbon hexachloride, and then trisulfur decabromide, these are two different examples. When you're looking at these things, all you have to do is read them, okay, and then write them down the way they is. Now, what does this mean? This means 2 carbons, hexa is 6, so 6 chlorines. 2 carbons, 6 chlorines, and you write the formula down. So, easy. Dicarbon, so that's C2, hexachloride, Cl6. So C2Cl6. Now, you have to remember this. Don't simplify or reduce the formula. Okay? Do you see how in ionic compounds you can totally take the 2 and 6 and reduce them, so it would be CCl3. Well, then that would be carbon trichloride, and we don't want carbon trichloride. We want dicarbon hexachloride, so you cannot reduce. Same thing for this one down here. Let's see. Trisulfur means 3 sulfurs. There we go. So 3 sulfurs, and then decabromide. Bromine, that's Br. Write down the symbol, but then this deca means 10. But that seems so much. Yeah, it doesn't matter. I don't know why you'd need trisulfur decabromide. Maybe it, I don't know, cures something. Warts. Sometimes you get into the habit of writing down exactly what you see. So be careful. Don't just go nitrogen octaiodide. Do you see how that is? Nitrogen. You could read it nitrogen octaiodide, but this would be wrong. What would this need to be? That would be octanitrogen monoiodide. So this is wrong. If we want nitrogen octaiodide, there's nitrogen, there's no mono, which means there's only one nitrogen, and octaiodide means there's 8 iodines. So you'd write down the symbol, and then this number's superscript. Superscript, look at me, subscript. So just be careful, and this takes some practice, but it is very simple. Good luck.